So, Niels Bohr, a Danish physicist, also worked under the guidance of J.J. Thomson. He agreed with the planetary model of the atom, but he refined this model by stating that each electron could move only in a specific path around the nucleus, called an orbit. Electron can move to a lower or higher orbit only by losing or gaining energy. This addressed the flaw in Rutherford's model, and in 1922, Niels Bohr received the Nobel Prize in Physics for the work on the structure of the atom. So, in due course, it was discovered that the nucleus of an atom was made up of two kind of particle, proton and neutron. Proton was first discovered by Goldstein and was named by Rutherford. Proton is a positively charged particle and weighs the same as a hydrogen atom, the lightest atom. A proton carries a single positive charge. Neutron was discovered by James Chadwick, right? And within the atom, now there are three different type of particle smaller than the atom itself. They are electron, proton, neutron, and are together called the fundamental particle or subatomic particle. So, what was the new arrangement now? Protons are there, neutrons are there, that is present in the nucleus, and electrons will revolve in different orbits having different energies. Okay, so this model do not collapse and it remains stable. So this remove the flaw in the Rutherford's model. Now the modern model of an atom is neutron and proton inside the nucleus, and electrons are moving around the nucleus in different orbits or shells, and these orbits or shells are having energies, different energy, right? So these shells are also known as energy levels. And the nucleus, which is containing proton and neutrons, these two together are called nucleons. Orbits, as I've told you, that these are also known as energy levels or energy shells. Electron revolve around the nucleus in these orbits only. The shell that is closest to the nucleus carries the lowest amount of energy, and as the orbit moves away from the nucleus, its energy increases. So from lower to higher level we have orbits which prevent the electrons to fall in the nucleus. So electron, proton, neutron, proton, neutron inside the nucleus, and electrons revolving in the different orbits or energy shells, right? Number of proton is equal to number of electron. Therefore the electrical stability of an atom is maintained. It is electrically neutral. Now atomic number. Atomic number is denoted by Z, and it is the number of electron or the number of proton present in an atom. If suppose in an atom two electrons are there, and we know that the number of electron is equal to the number of proton, or we can say the number of proton is 2, so that is the atomic number of that atom, and it is denoted by Z. So atomic number is denoted by Z is equals to number of electron or number of proton. Next we have mass number. These are the terms related with the number of electron and protons or neutrons. Mass number is the number of protons plus the number of neutrons, or we can say it is the number of nucleons present in an atom. So number of neutrons, if mass number is known, if we subtract the atomic number, we'll get the number of neutrons. And if we want the mass number, we'll add the number of proton and number of neutrons. Suppose uh, an atom is containing 5 protons and 6 neutrons, so mass number will be 5 plus 6, that is 11, right? Atomic number denoted by Z, mass number denoted by A. And symbolic representation of an element using atomic number and mass number is, you can see here, A, Z, X, A and Z both are on the same side or on opposite sides, but Z remains at the bottom, A remains at the it is a superscript, right? So if we can take the example of oxygen here, right? Oxygen, the mass number of oxygen is 16 and atomic number is 8, so it can be written as 8O16, whether 8 and 16 both are at the same side or on opposite sides. So an atom X has atomic number 12 and mass number 24, right? So if you have to calculate the number of neutrons in it, you will subtract the atomic number from the mass number. 24 minus 12 will give you the number of neutrons.